if we're adding, like if we added 1 plus 2 plus 3 plus 4, that we could rewrite that as the sum from k equals 1 to 4 of k. And this sigma notation tells us it's going to start at k equals 1. If I saw the sum from q equals 4 to 9 of 5 to the q, what would that be? Just keep changing the value of the exponent q, and every time you come back around, you get you update that value based on what q is, and then you just are adding them all up. There's another notation that's similar that we use for multiplication. It's just called product notation, and it's represented by a very large pi. So it kind of looks like gates. And it's the same thing as summation, except we're adding instead of multiplying. So if I have the summation from t equals 1 to 5 of t, that would be equal to 1 times 2 times 3 times 4 times 5. And I'm not going to ask you if you agree because I just defined this. So there's nothing really to agree or disagree with. This would also be capable of being written as 5 factorial, and that would work perfectly well. Factorial is really a special case of this. This is the same thing as that. I don't have to do it with just the single t, just like the summation. I could put a power on t, and I don't have to start it at 1. I could do, for instance, t equals 3 to 7. The product from t equals 3 to 7 of t squared. So this is a tool that just lets you multiply through. And in the special case where you start at 1 and go up to something, it is the same as a factorial. I introduced this notation. Look at the ways we were looking at this problem before with selecting a things out of n things. Now let's look at this. How many ways could we select 4 books out of 8? And let's see if we can rewrite this with product notation. So how could I rewrite the numerator going from 5 to 8 multiplying? And then I'll probably use a different variable for the denominator. Let's say r equals 1 to 4 of r. If you want to, you could certainly r factorial on the bottom, and we could have t equals 5 to 8. Product from t equals 5 to 8 of t. So either one of those is okay. So we've reviewed how to count the number of selections, and now we've been able to rewrite these selections using product notation to express repeated multiplication. Let's look at this special case where we're not necessarily starting at 1. And now my question is, what if I'm not starting at 1? What if I'm starting at 4? Is there a way to write this as a single factorial or as a ratio of factorials or anything I can do? So it's going to be 4 times 5 times 6 times 7. And I can put 1 times 2 times 3 on the bottom, and that's 3 factorial. Cancel those out, and these are all equivalent expressions. So in general, what if I didn't have 4 and 7? What if I had the product from q equals k to n of q? So I'm going to have k times.
That's the same as it's like n factorial over n minus k factorial.
Let's see. So if I do n factorial over n minus k factorial, let's do a reality check with the numbers we had up here. So up here we had k equals 4 and n equals 7. So 7 minus 4 would have been 3. So it matches up there. Do y'all agree? And you can look at writing it out to where you actually look at this, because you can do the trick that we did before where you go up from 1 to n, and then you write another product where you're splitting it, and you kind of look at, okay, where do things cancel here? Sorry, this should just stop at the n minus k. So then these cancel out. So how many of these cancel versus how many are you left with? Well, you're going to have k left over, and you're going to be left with the right things on top. So these are also all equivalent. And it's good to know these things about how all of these work together. Sometimes you want to express one as in another form.